Hello everyone, you're welcome to my solution to question 4 of the Cambridge IGCSE Mathematics written in May-June 2024. If this is the first video you are seeing in the playlist, kindly check my channel. There is a playlist where I already have 3 videos for questions 1, 2, and 3 respectively. So if you are seeing this channel for the first time, please kindly subscribe to my channel by clicking the subscribe button. Also hit the notification bell to receive a notification anytime I upload a new video. Like, comment, and share this video. Question 4a. The diagram shows a tank in the shape of a half cylinder of radius 12 centimeters and length 1 meter. The tank is fixed horizontally and is completely filled with water. Calculate the volume of water in the tank. Give your answer correct to the nearest 10 centimeter cube. Okay, so this is a cross section. Okay, to get the volume, okay, it will be the cross section area multiplied by the length. Okay, so that will give us the volume of this shape. Okay, so the radius is given as 12 centimeters. You can say r is equals to 12 centimeters, and the length, let's say l is equals to 1 meter. So it equals to 1 meter is equivalent to 100 centimeters. Okay, so if you use the acronym, King Henry died by drinking chocolate milk. Okay, so this is the base where you have the liter, you have meter, and you have grams. Okay, so for you to convert meter to centimeters, so you move 2 times 1 and 2, that is 10, each is 10, so 10 times 10, that is 100. Okay, so you move twice. Okay, so that's how you have these 100 centimeters. Okay, so let's continue with the solution. So to calculate the cross section area here, so this is a semicircle. Okay, so the area of the cross section is equals to the area of a circle divided by 2. So you can say cross section area, cross section area, so that will be equals to pi r squared over 2. So let's scroll down a little bit. Okay, so pi is equals to 3.142 multiplied by radius 12 squared and divided by 2. Okay, so if you input this, okay, so this will be the cross section area. Okay, and we can get the volume now. So the volume will just be the cross section area times the length, which is 100 centimeter. So I think I can do that straight away. So you can say the volume, okay, so will be equals to this cross section area, that is 3.142 multiplied by 12 to the power of 2 divided by 2. So this is the area of this cross section. Okay, so the cross section is a semicircle because this is a cylinder and it was divided into 2, so it will be a semicircle. Okay, then multiply by the length, which is 100 centimeter. Okay, 100 centimeters. Okay, so if you input all this into your calculator, so you get the value to be 22,620 centimeters, so the nearest 10 centimeter cube. Okay, so I'll put 22,620, so that is what I'm going to have here. So let's check the Roman figure 2. Roman figure 2, water is removed from the tank until the level of water is 6 centimeters below the top of the tank. The diagram shows the cross section of the tank. Calculate the volume of the water that is now in the tank. So we need to construct some lines here. So don't forget that the radius is 12 centimeters. So if you put a pair of compasses here, okay, and you draw here, so any point from this center of the circle, okay, so to the arc of this circle, okay, will always be to the circumference of this circle rather will always be the same radius, okay, will always be 12 centimeters. So it means that if from here to here is 6 centimeters, that is from here to this place is 12 centimeters rather, that's the radius, 12 centimeters. Okay, so the implication is that from here, okay, to this side, okay, will also be 12 centimeters. So the same thing goes for this. You can take it like this too. Okay, so that would be 12 centimeters. Okay, and this will also be 12 centimeters. Okay, as you still have the radius along this circumference of the circle. Okay, so from the center of the circle. Okay, so now what we want to do is that this particular shaded region is the new cross section. So we need to get the area of this cross section and multiply by the length. Okay, so that will give us the new volume of water. Okay, so but this cross section, that is the shaded region, is a segment. Okay, so that means we need to get area of this segment. So to get the area of this segment, so we need to firstly get the area of the whole sector, that is from here, okay, up to here, then back to this place. So the sector is made up of a triangle and a segment. So once we find the area of the sector, then we also find the area of the triangle. So we subtract the area of the triangle from the area of the sector. So that will give us the area of the segment. Okay, so and that is what we need to do, and we can use that to get the volume of the water now. Okay, so the first thing we need to do is to calculate the area of a sector. So the area of a sector is giving us, let's write area of a sector so it's equals to theta over 360 times pi r squared. So we know the radius, we know the pi, so the only thing is we don't know the theta. So if you look at it, this is what we need. The whole of this will be the theta, okay, but we can find this bit by bit. That is, let's call this theta 1 and this one should be theta 2. Okay, so our theta will be theta 1 plus theta 2. So we can write it here. So theta equals to theta 1 plus theta 2. That will be the center angle. Okay, so to get that, we can use this triangle here. So this is the opposite, this is the adjacent, and this is the hypotenuse. So we know the adjacent and the hypotenuse, so we can use cos theta. So from there we say cos theta equals to the opposite is 6, adjacent rather is 6, and the hypotenuse is 12. So we have cos theta to be equals to 0.5 or 1 over 2. Then take cos inverse of both sides. That will give us theta to be equals to cos inverse of 0.5. And of course, that is obvious. This will be 60 degrees. That's theta 1 rather, cos theta 1. Okay, cos theta 1, cos theta 1. So theta 1. Okay, so now that we know theta 1, so we can say that theta equals to theta 1 plus theta 2, and that will be equals to 60 plus 60. That will be equals to 120 degrees. So this is the value of our theta now, the center angle. Okay, So once we know this, then we can now find the area of the sector now. So therefore, so we can draw a line like this to demarcate this. So the area, okay, is equals to theta, that is 120 over 360 times the value of pi is 3.142, then times the radius, which is 12 squared. So there's no point wasting time. You can input the whole of this into a calculator, and the area of the sector should be 150.816 centimeter squared. So next we calculate the area of a triangle. Okay, so let's divide this like this. Oh, sorry, that is bad. So let's draw a line like this. Good. Okay, so you can say area of a triangle. So will be equals to that's the base and the height now will be, according to this formula, we have r squared, okay, multiplied by sine theta, everything divided by 2, okay, because we know the two sides and one angle of the triangle. So this is the correct formula. So if you key in the values, okay, so this will be 12 squared times sine, so theta will be equals to 120. Okay, so that's our theta here, that is theta 1 plus theta 2. Okay, so everything divided by 2. So you can input this into a calculator and get your answer straight away. So this will give you 62.354, 62.354 centimeter squared. Okay, that's the area of the triangle. So the area of the segment now. Okay, so area of the segment, which is the cross section that we need, area of the segment, so will be equals to area of the sector, okay, which is 150.816, then minus area of the triangle, which is 62.354. Okay, so if you subtract this, so you should get 88.467. It's 8.462 amount, so it will be 88.462. So that will be the area of the segment, okay, which is the area of the cross section. Okay, so area of the required cross section is 88.462. So finally, we can now calculate the volume of water. Okay, so volume of water now, okay, so that is now in the tank, will be equals to the cross section area, which is the area of the segment, that is 8.462 multiplied by the distance between the two cross sections, that is 1 meter, which is equivalent to 100 centimeters. Okay, and if you do that, so this will give you 8.850 centimeter cube. So 8.850 centimeter cube. So that will be the volume of water that is now in the tank. Okay, so a rectangular fish tank with length 42 centimeters and width 35 centimeters is full of water. So a stone lies at the bottom of the tank. So when the stone is removed from the tank, the depth of the water decreases by 0.2 centimeters. So the density of the stone is 2.2 grams per centimeter cube. Calculate the mass of the stone in grams. So we are given the formula of density to be equals to mass over volume. Therefore, mass will be equals to density multiplied by the volume, that is the volume of water gained by the stone, and we've been given the value of density to be equals to 2.2 gram per centimeter cube, equals to 2.2 grams per centimeter cube. So we need to get the volume of water gained by the stone. So that is what we need to get. So once we get this, we can easily get the mass of the stone by using this formula. Okay, so let's sketch the rectangular fish tank. We have something like this. Okay, let's draw something like this. Then you have another one like this. So this is just a rough sketch. Okay, something. Let's scroll up a little bit. Okay, yeah. Then you have something like this. Good. So let's try to draw another one like this. Okay, I think I can use this one here. Good. So let's draw this. Good. So have this. Okay, so we have another one. Okay, here. So we can easily join this together. Something here. Then this. Okay, then let's join this and this together too. Okay, good. Okay, so let's adjust this a little bit. So let's drag it down here. Okay, good. So from the statement, or from the question rather, okay, so we have the length to be 42 centimeters. So I'll put 42 here. So this is 42 centimeters, and the width is equals to 35 centimeters. So 35 centimeters. Okay. Then from the question, when the stone is removed from the tank, the depth of the water decreases by 0.2 centimeters. So before it was full, okay, up to this point, okay. So when it decreases by 0.2, that means from here to somewhere here, okay. So let's do this, something like this. So this will be 0.2 centimeters, that is from here to this point. Okay, so let me label this to be point A and this will be point B. So that will be 0.2. So the new level depth of the water will be from B to C. Okay, so this is the reduction. The reduction is 0.2. Okay, so from the top of the tank. Okay, so that is what we get from there. Okay, so I can equally do the same thing here. So let's make it around this. Okay, then you can also have the same thing around this side. Okay, so and you can also do the same thing here to make it more realistic. Okay, so what we want to get now, the shaded, let me shade this now. This shaded region, okay, so is the volume of water gained by the stone, because when the stone was removed, okay, so the water reduced to this level. Okay, so it means that that is the volume of water gained by the stone. Okay, so the volume of the shaded region, okay, will be the volume of water gained by the stone. Okay, so and of course this place is 0.2. Okay, and this place will remains 35 centimeters. Okay, because this and these are opposite sides of a rectangle, so this place too remains 42 centimeters. Okay, so we can now calculate the cross section area of this shaded shape. Okay, so the cross section is a rectangle with length 35 width of 35 centimeters, and then I think the height is 0.2. So can do the product of these two will give us the cross section area. So let's write here. So can demarcate this like this. So you can say the cross section area equals to 0.2 centimeter multiplied by 35 centimeters. Okay, then the volume of water gained by the stone. Okay, so you can write the volume, okay, of water. Let's write this: the volume of water, okay, gained by the stone, so will be equals to the cross-section area, which is 0.2 times 35, so multiplied by the length between the two cross-sections. Okay, that is this and this. The distance between this and this is 42. So that means you're going to have the cross-section area 0.2 multiplied by 35, that's the cross-section area, then multiplied by the length between the two cross-sections, that will be the volume of water gained by the stone. Okay, so if you do this, so you will get 294 centimeter cube. And finally, you can get the mass of the stone. The mass of the stone, so will be equals to the density, which is 2.2 gram per centimeter cube, multiplied by the volume of water gained by the stone, which is 294 centimeter cube. So if you do this, you get 646.8 grams. So you have 646.8 grams. So let's go to the next question, that is part C, which is the last question in this video. Okay, the diagram shows a cuboid A, B, C, D, E, F, G, H. Calculate the angle that the AG makes with the base of the cuboid. Okay, so let's identify the angle. So before then, let's draw a line from A to C. That will be on the surface of the base. Okay, and the required angle is this angle, okay, which is theta. Okay, so we need to find AC. Once we know AC, then we can use tangent to get this angle. Okay, so let's find the length AC. Okay, so AC squared. So AC squared is equals to AB squared plus BC squared. That's Pythagoras theorem, and AC will be square root of. So let's do this: AB squared plus BC, okay, squared. So this should be squared, or this, okay, not B, okay, this and this. Okay, so let's write this very well. Okay, so we have squared here. Okay, so if you input the values there, so AC will be equals to square root of AB is equals to 8, so we have 8 squared plus BC, which is 12 squared. So if you do this, AC will be equals to, sorry, let's write this very well. So this should be 12 then squared. Okay, so AC will be equals to 14.4 centimeters. Okay, so from there, this is what we have from this diagram now. Okay, we have ACG, so let's sketch that. Okay, so we have something like this. Okay, then we have something like this. Okay, good. Then we have something like this. Okay, so that is what you have. So let's adjust this a little bit. Okay, good. So we have point A here, point C here, and point G here. Okay, so this is theta, the required angle. So this is 15 centimeters, and we found this to be 14.4 centimeters. So using tangent, that is opposite over adjacent, so we have tan theta equals to opposite, which is 15 centimeters, over the adjacent, which is 14.4 centimeters. So theta will be equals to, if you take tan inverse of both sides, so tan inverse will cancel tan, so we're left with tan here. So we have tan inverse, so open a bracket, 15 over 14.4. Okay, so if you input this, all this into your calculator the way it appears before you, so you should get the value of theta to be 46.2 degrees. Okay, so that is what you should get here. So 46.2 degrees is the angle that the line AG makes with the base of this cuboid. So this is the end of my solution to question 4. So in the next video I'll be solving question 5. Until we meet again, have your fingers crossed.